Hello everyone, welcome to my channel. So today we are going to do Leetcode Biweekly challenge. Second question, find if array can be sorted or not. So let us first read this question, then about constraint, and then finally the coding part for the same. So you are given a zero index array of positive integers num. In one operation, you can swap any two adjacent element if they have the same number of set bits, and you are allowed to do this operation any number of time, including zero. And we are required to return true if you can sort the array, else return false. Basically, we are required to sort the array, but there is one condition that you can sort the array by swapping the numbers which have same number of set bits. So that is the whole question, and that is what we are required to do in this question. If we see this first example, so here we can sort only these three because they have same number of set bits, and we can sort only these two with each other by swapping because they have same number of bits as per mentioned in this explanation. Now the thing is, let us check for constraint, which is like num's length is up to 100, so that simply means that we can go ahead with n square and log n solution. And here each number can go up to 2 raised to power 8, so that means we can easily check for 32-bit set criteria. Now here the part is that we are required to check the number of bits which are set in this whole array, means all the bits we are required to check, and then swap all those which are with each other. The point is that we can swap those which have similar bits, right? So how we are required to proceed with the coding part for the same would be that we will be checking the all the adjacent which are there. If all those are having same number of bits, right, then we will be easily able to swap. And if they don't have, then we are required to return false from there. But the point before that is that we will be taking one auxiliary array in which we will be storing the sorted elements of this particular array, and we will be comparing with the same. That if the present element and the element in the input, if they are same, then we will be continuing, we don't need to do any operation, right? But if they are not, then at that moment we would be required to do the operation, and that's where comes our further coding part. So let us go ahead with the coding part for the same. So here, first thing what we are doing is, here we are checking for the number of set bits. That is what we are doing here, and pushing all those set bits into this bits vector. And this whole operation goes ahead with order of n, and this is 32 bits, so order of 32. So that's why overall it becomes order of n time complexity. Now the next part which comes is, at the start I mentioned that we will be taking one auxiliary space, just where we will be keeping the sorted ones, right? So that is what we are doing here, sorting that particular. And now here we are taking one more loop in which we will be storing the present element, is taking that element from the sorted, and we will be comparing that with the input. If they are same, then we will be continuing. That simply means that it is already sorted, and if it is already sorted, then why we need to do anything for the same? But if that is not the case, then what we will be doing is, we will be taking the present bit from that bits of I, is at that moment what is the bit which is there, and here we are taking one index which we are taking just for the fact that we will be storing